Practice 4-3. Now we're just using ASA and AAS, angle, side, angle, and angle, angle, side, to decide, do we have enough information here to establish that an angle, a side, and an angle match up to an angle, a side, and an angle in these two triangles? Well, let's see here. Hey, they're right triangles. This is great. Section 4-6, we're going to really go in depth with our right triangles. But let's see here now. Do I have enough information to do angle, side, angle matched up with angle, side, angle? Well, all right triangles are congruent, so there's my one. There's an angle. It matches up with this angle over here. Oh, look, I've got a side that's noted with a little hatch mark. That goes over with here, and that's it. I get nothing. So this is not possible with angle, side, angle, or angle, angle, side, or anything else for that matter. Number 2, do I have enough information to use ASA or AAS? Well, let's see here. We've got this, you know what, let me increase this a little bit. There we go. We have this angle matched up with this angle. That's lovely. Now, can you imagine these two triangles sort of pulled apart a little bit? That might help. But we know that TV is congruent to itself. So now we've got an angle, we've got a side, and let's see here. Oh, yep, look at that. Inside this lower triangle, I've got my double arc mark angle down here. Okay, that matches up with a double arc mark angle up here. So that means I have angle, side, angle. So ASA on number 2. Next, we have an angle. We have a side. Anything else? Yeah, look at that. You can always assume that angles that appear to be vertical are vertical, that these are really, truly straight lines. So that means this guy congruent to that guy. Hello. Now then, what could this be, therefore? I got an angle, and then a side. Yeah, that's exactly it. It's angle, angle, side. So as I point to these things that I know for sure are congruent, and I say what they are, I know that this angle is congruent. Whoops. I know that this angle is congruent over here, and I know that this side is congruent over here. As I go around the perimeter and I say those things in that order, that is the triangle postulate or theorem that works. Number 4, we've got an angle. We've got a side. Oh, and look, this must be our other angle. So what's it going to be? Would you call this angle, side, angle? Or would you call it angle, angle, side? Or actually, let me try it this way. Angle, angle, side. Well, here's the thing. The answer is angle, angle, side. Because if you started with this guy here and said, well, let me say I got this matched up with that. So there's one angle. Then I got a side. But you know what? If you skip over this guy, which we know nothing about right now, that it's angle B that has to be the angle you need if you were to use angle, side, angle. But you don't know anything about B, so that's all a waste, a wash. What you know is this angle, and see, I haven't skipped over anything. I can go from one angle to the next angle and then trace a side that I know for sure matches up. Now I know I've got angle, angle, side. I guess it's okay if you wrote SAA, but that just doesn't ring quite as right for me. So let's call this AAS. Number 5, do we know enough information? Hey, we got vertical angles. How you doing, buddy? Yeah. Okay, so now we've got an angle, angle, matched up with another angle, and don't know anything about G, don't know anything about H. But I know a side. There's nothing that has just 2 parts. Again, when we get to section 4.6, we will have the 2-letter codes, but they'll be H's and L's for hypotenuses and legs. Right now, we do not know enough about number 5 to make these triangles congruent. So by the same logic, I'm over here with an angle and a side. I get nothing. Not enough information. Number 7, let's see. We've got an angle, a side, and an angle. Yay! And those match up with the angle, the side, and the angle. So this one was easy. ASA. Got it. How about over here? Ooh, let's see. I get a side. I get ZB congruent to itself, so I could sort of make that hatch mark that I've got another side. But it doesn't show me that there are any parallel lines, so I don't know anything about these angles in here being congruent. Question mark, question mark. So number 8, not enough information. Number 9. Oh, hey, you know what? I see some vertical angles. I'm going to go ahead and mark those. Yay, you're vertical, so you're congruent. So what have we got here? Let's see here. Oh, I got an angle. Then the next thing I come to is an angle, and the next thing I come to is this side. Oops, see, there it is. Angle, angle, side. You want to see that again? Let's see that again. That was a little blurry. These are congruent because they're vertical. So now I start here at my far side angle. I go to an angle, I get another angle, and then the side. Number 10, write the 2-column proof. If we start with these givens, you know what, I'm going to sort of write right over this. Number 1, here's my statement, because in my reasons column, that's a letter A, given, not a number 2, A. Next statement will be MLP congruent to KLJ. And why are those 2 angles congruent? Oh, I should use 2 hatch marks. Yep, because they're vertical. So that means, let me clear this up, except for, of course, my vertical angle arc marks. So now I look at this and I see an angle, a side, and an angle that match up with the angle, side, and angle from another triangle. So sure enough, third statement, I've got JKL congruent to triangle PML because they are ASA, angle, side, angle, congruent. Number 11, 2-column proof. 2-column style. So, statement number 1, all this stuff, why? Because it's given. Statement number 2, again, I'm sorry my A's look sort of 2-ish. So now, what's my next statement? All I know is that I've got an angle congruent to an angle, that was right here, and that I get this guy congruent to this guy. So hey, I see angle, angle, side. So let's talk about TR congruent to itself because of the reflexive property. And my last statement is the triangle, that QRT really is congruent to triangle STR. Why is that? Well, let's clear this up for a second here. What have we got? Well, TR congruent to itself, that's like having a hatch mark on in these 2 separate triangles. So I can go from this angle up to this angle and then trace the side. And that matches up with this angle, and the side. So my reason for number 3 is angle, angle, side. I've proven these 3 things. That makes the entire triangle congruent to the entire other triangle. So if we're trying to use ASA in number 12, angle, side, angle. What side are we missing? Is it AB? Is it AC? Or is it BC? The answer, BC, is what we need. So you can make hatch marks as many as you want. Try not to obscure the entire line. So you need to see that BC is congruent to EF. And I'll even write that because that's really the true answer here. This segment congruence statement. Now here, if I'm trying to prove angle, angle side, well, the side must be this one that they're talking about. And let's see here. I've got this angle. So if I'm trying to go angle, angle, side, I could either go from here and then go up to this angle. There's 2 arc marks. And then talk about this side. Or could I go the other way? Could I use the angle that they gave me? And what if I knew something about this angle and then move to that side? Either way is okay. So you can have 2 correct answers here for number 13. And it would be either G congruent to J, or, well, let me use a different color. Here we go, blue. And I'll use double arc marks on that one. Or we could call this, now I can't call this angle K because there's actually 2 angles here, so I have to name it with my 3 letters. H, K, G would be congruent to K, H, J. So either one of these would be fine. And now, what are we missing if we're trying to prove these 2 guys are congruent by angle, side, angle? Well, this is the side. That means I need both angles. I need this guy congruent to this guy, and I need my vertical angles congruent. So what I'm missing is angle L congruent to angle P, and angle LNM, meaning from here to here to here, so this guy has to be congruent to angle PNQ. If I knew these 2 things, then these 2 triangles would be congruent by ASA.